Number 1, write the polynomial in factored form. So the first thing we're going to do is make sure that it's in standard form, meaning descending order of exponents, and it is 3, 2, 1. Next thing we want to do is factor out any greatest common factor, and there is a greatest common factor of x. So x parentheses x squared minus 4x minus 21. We can now factor this trinomial. We have x and x. We need two numbers multiplied to give you negative 21, but add to give you negative 4. That would be a minus 7 and a positive 3. And it's completely factored. Number 2, find the zeros of the function. It's already in factored form, so the zeros are going to be negative 1, positive 1, and positive 2. The next thing we want to do is graph the function. So first graph the zeros. So we have negative 1 here, positive 1, and 2. Next thing we want to do is get the graph of it on the graphing calculator. So it was x plus 1, x minus 1, x minus 2. So if we hit second table, we'll see some other points that we can plot. Negative 2, negative 12 is down here. We already plotted negative 1, 0. 0, 2 is here. We plotted 2, 0 already. 3, 8 is right there. So now we have some additional points here. Now what we want to do is we want to find the local max and mins of this. So second trace max, left bound, right bound, guess. So at negative 0.2, 2.1. So right around here. And then the local min, we'll do second trace 3, left bound, right bound, guess. 1.5, negative 0.6. So 1.5, negative 0.6 is right around there. Now looking at the graph here, we want to basically make the same shape with the points that we have here. So we'll go up, down, then back up again. This part right over here is a little bit off, and I just erased that point here. So let's just do this over again. Just erased it again. That stupid point. Alright, let's see if... there we go. Alright, let's see if this is better. There we go. Put arrows at the end and you've got your graph. Okay, number 3. Write a polynomial with the given zeros. So the 0 of 0, you just want to put x there. 4, you're going to have x minus 4. And negative 0.5 would be 2x plus 1. Because negative 0.5 is the same as negative 1 over 2. And if you remember back in chapter 4, the denominator was the coefficient of x when you put it back into factored form. So they want you to write this in standard form. So what we're going to do is we're going to multiply the first two first. So x times x is x squared. X times negative 4 is negative 4x. And then FOIL this out to get your final answer. So 2x cubed plus x squared minus 8x squared. So that would be minus 7x squared minus 4x. And that's your answer. Number 3, find the zeros of the function. The zeros of x plus 1 is negative 1. So I'll put the zeros here. And then we'll write the multiplicity underneath it. X minus 1 gives you a 0 of 1. X minus 2 gives you a 0 of 2. Negative 1 shows up twice, so the multiplicity is 2. This and this show up once, so those multiplicities are 1. Number 5, relative max and relative min. What you want to do is definitely graph this problem. Let's clear this out. So we're going to have negative x cubed plus 16x squared minus 76x plus 96. So it looks like it goes down, then back up again. So what we want to do is we want to see what happens under here, because we need that relative min. We have the relative max here, but we need this one here. So let's extend the window for the minimum max. So instead of only going down to negative 10, let's make it go down to negative 30 and see if we have all of it. Yep. So we want to find the relative min here and the relative max there. So second trace 3. And that's to the left of it. That's to the right of it, and then guess. So 3.57 comma negative 16.9. 3.57 comma negative 16.9. This was the relative minimum. The relative max, we're going to find out right now. Second trace 4. Up to the left here. And then to the right of it. Let's call it 7.1 comma 5.05. Whoops. Let's do 7.1 comma 5.05. And you're done. This one, again, we're going to need the relative max, the relative min, and the zeros. So let's get the calculator out, clear this out. 2x to the third minus 23x squared plus 78x minus 72. Let's graph that. So let's just extend it a little bit higher on the max here. So we'll go the y max, let's just go to 20. So we have the relative max, the relative min, and our 3 zeros here, here, and here. So let's do the relative max first. So that's to the left, to the right, and then enter. So 2.53 comma 10.5. 2.53 comma 10.5. That's your relative max. Second trace 3 for the min. There's to the left, to the right, and then guess. 5.14 negative 7. Let's just do 5.1 and negative 7.1. Now for the zeros. We see here, and we can consult our table, but it looks like 4 and 6 are going to be zeros. And we can check just to make sure. 4 comma 0, so we know that's definite 0, and 6 comma 0. So just by looking at the graph, we're able to see that it goes right through 4 and 6. And you definitely want to check your table to make sure that that's exactly true, because you never know. It could be 4.1 or 6.02, something like that. So 4 and 6 are definite zeros, and we need to find this 0. So we'll do second trace 2. We'll go left bound, that would be just under it, just before it. And then right bound would be just after it, and then guess. So that 0 is 1.5. So 1.5, 4, and 6 are your 3 zeros. Four and 6. I may have said 3, I don't know, but 1.5, 4, and 6 are your 3 zeros. Number 7, solve by using any method. Let's use completing the square, just for fun. You don't want to forget any methods that you've been learning throughout the year, so don't always stick with one method for solving or for doing any particular problem. You always want to be making sure that you're challenging yourself, number one, and that you don't forget things, different methods of doing problems. So like for this one, don't always do completing the square, or don't always use the quadratic formula. Change it up. So first thing is moving the constant. Next thing would be factoring out the lead coefficient. It's 1, so you don't have to do that. So we leave a space. You fill in this space by taking half of that and squaring it. Half of that is 3/2. Squaring it would be 9/4. So you add 9/4 here. This becomes a perfect square. It's x plus 3/2 squared equals. If I make -1 in terms of 4, it would be -4 over 4. A -4 plus 9 would be a 5. So it would be 5 over 4. You want to take the square root of both sides. I'm making this a 2 down here because when I take the square root of 5/4, I can split it up as the square root of 5 divided by the square root of 4, and I know that the square root of 4 is 2. So I'm going to split it up automatically. And then when I subtract 3/2 over, it's all going to be over 2 because it shares the same denominator. So this is your solution. And you would have gotten the same thing had you used the quadratic formula. Alright, determine the end behavior. It's written in standard form, except for these two, so you could flip these around. But the idea is that the lead term is the correct lead term here. It's a positive, even function. That means the ends are both going to go up. It doesn't matter what happens in the middle here. It doesn't matter inside here. What matters is that the ends both go up. So the limit as x approaches positive or negative infinity is going to be positive infinity. Number 9, they want you to factor. So it's an easy trinomial. So x and x, two numbers that multiply to give you 4 but add up to 5 would be 4 and 1. That's factored. Number 10, explain how the vertical line test is used to determine whether a graph represents a function. So the first thing we have to talk about is, what is a function? A function is a special kind of a relation. It's a relation where each and every input only has one output. In other words, for every input there can only be one output. An input cannot have more than one output because then it would cease to be a function. I mean, you can have them, you can graph them, it just means that it's not a function. So a vertical line test can help you determine whether it's a function, because, for example, if you have a graph like this, if you think about it, every one of these inputs only has one output. That has an output of here, one output, one output, one output, one output, one output. That means that if I were to draw a bunch of vertical lines, I would only hit it once, no matter where you draw it. What happens if you have more than one output? For example, 2. Let's say in the equation, if you plug in 2, you get 1 and -2 out of it. That input of 2 gives you 2 outputs. You no longer have a function. So try to draw a vertical line at 2. What happens? It hits more than one place. That just shows you that it's not a function. So the vertical line test is a test that if you draw a vertical line through a graph, if it hits more than one place, it's not a function. If it only hits one place, no matter where you draw it, it's a function.